and I can't really cope with these temperatures. My name's Sufyan Kazi. People call me Suf because it's only got 3 letters and it's a lot easier to pronounce. I work for a company called Pivotal. How many of you have heard of Pivotal? Wow. That's actually a better response than I get from most people. If I press a few buttons, eventually this will come on the screen. Pivotal are very good at working with TVs, clearly. How many of you have heard of, have actually used Cloud Foundry? You're not allowed to respond. That's perfect. That's good.
That was going to happen.
How many people know what Pivotal do? He's not allowed. Okay, good. This is perfect. Okay, last question I'm going to ask, hopefully. How many of you are developers? Those who didn't put your hand up. IT operations? Ish. Okay, DevOpsy, something. Something like that. Okay, cool. So I thought I'll start off with who are Pivotal and what we're all about. There's 3 main areas to our business. We have a product called Pivotal Cloud Foundry, which I'm going to explain today. What it is all about. We have a product called Big Data Suite. It's actually a combination of products. If you've heard of Greenplum, Jamfire, lots of vacant expressions. A lot of our data products are now on the Apache incubating side. So Apache Geode, Apache Hawk are our technologies. And then we have a sort of part of a business called Labs, but we won't mention them because they're sort of complete with Fortran. So let's move on from there. If you want to know more, we've got a YouTube channel. You don't need me to come and stand up here and tell you all about it. Loads of videos from engineers, from people working in Pivotal, people talking about diversity, people talking about future roadmaps, if you're interested in all of that. How many of you use a Spring framework, Java, or have done? Did any of you know that Pivotal own the Spring framework? Cool, because normally people don't know that. So we are the custodians of Spring. People who like the Spring framework are employees of Pivotal. We are the custodians of RabbitMQ, if you're familiar with that technology. A while ago, we were the custodians of Redis. We still work closely with the founder of Redis. He now works at a company called Redis Labs. We had Spring One recently. If you check out our channel, there's loads of videos of people talking about what the future roadmap of Spring and what we're doing. That's me. Tweet me, email me, whatever you want to do. I'm going to be sticking around for a bit as well. Enough of the corporate stuff. What are we going to talk about today? So why does Cloud Foundry exist? So I kind of tried to think about this from a perspective of me as a humble developer writing some code, and I check that code into some source control, maybe GitHub. And the reason I want to check it in is because I want to execute it somewhere. I want to start off a pipeline which builds that code, runs and tests against it, and maybe release it. So I built an artifact. Maybe I'll use Gradle, Maven, whatever I need to do, depending on the application I'm building. Clearly, you can tell I'm a Java guy. That's my background. Now I need somewhere to run this application. Now, I know I've got youthful good looks, but you might not realize I was writing code a long time ago. In the 2000s, I used to work for a company that's famous for having a blue logo and 3 letters. It stands for I blame Microsoft. That's what they. And we never, well, containers and all that kind of stuff didn't used to exist in those days. It was all about VMs, and we used to have to secure shell into a server in Warwick, and then secure shell from there to another server, which is where our application was going to run. And we had to use the best product in the world called WebSphere to deploy our code into, and it was amazing. Nowadays, it's a bit simpler. But there's still some problems. If I want to get my code to run nowadays, I need to package it up somewhere. Maybe I could create a Docker container. Cool. If I am creating a Docker container for my code, what am I checking into GitHub? Am I checking in the configuration of my Docker image as well? Is there sort of a relationship that I've artificially created? Maybe, maybe not. Some of the customers we talk to do seem to think that way. There's a sort of a interconnectivity, and their code is getting a bit confused. It'll only run on this image, and so you need to be aware and keep that intertwined, which creates other problems. If you need to upgrade the operating system, then which apps are affected, which containers are affected, who's maintaining that library, who's scheduling the workload, where those containers are going to run. There's loads of tools out there. I could use Kubernetes. I could use other tools to kind of orchestrate my Docker containers. It's not simple. How many of you guys use Docker, by the way? Okay, so speaking to an audience. And there's nothing wrong with Docker. I'm just saying that there's problems with just a pure container-based approach. And those problems repeat because I need to think of a solution for running my code in development, in other test environments, in pre-prod and prod. Then I need to think about what I'm going to do when I modify my code and release version 2. When my code is running, how do I patch it? How do I simultaneously have a second version of my code running and switch between one to the other? How do I know what the network path is and the routes to access this application are? I need a bit of help. So there's all these crazy buzzwords, which people in marketing have invented and said that this is the answer to all my problems. A bit of DevOps, a bit of microservices, a bit of containers, continuous delivery. A long time ago, someone at a company called VMware, which I think some of you have heard of, hopefully, created this concept called Bosch. How many of you have heard of Borg, Google's Borg? So if you heard of Kubernetes, it's a subset of Borg. The white paper of Borg came out quite a while ago, and they released a sort of more public version of it now. So this guy took Borg and said, I'm going to make something slightly different. So he incremented a couple of letters, and that gave him Bosch. And Bosch stands for, well, the B stands for Bosch. So it stands for Bosch Outer Shell. It's a recursive acronym. The team who built it, most of them are still around at VMware. Some of them, one of the guys has now started working at a company called Appsira, which is another PaaS. The idea of Bosch is, it's a sort of a thinking machine. You give it a description of a set of VMs you want to create, and it goes off and talks to vSphere and creates a bunch of virtual machines. So you give it a recipe, it comes back with a set of running machines, network connectivity, operating system installed. Kind of like a Cloud Formation script for AWS, except a long time ago, just for vSphere. And then what Bosch will do is then it will say, hey, I've got all these VMs running. I'm going to look after them, I'm going to monitor them. And I'm going to keep an audit of what OS they're running and what libraries they're running. So if you need to upgrade them, I know which ones are affected, which ones need patching. If one of those VMs crashes, I'll resolve it. And that was the starting of something. But it's not really going to solve my problem of, where do I run my code and how do I kind of version control stuff. It was the beginning of what became this idea of a PaaS, a platform. Okay, and what was missing was, okay, now I've got this orchestration for building machines. What about network routing? What about centralized logging? What about health monitoring? What about access to other services like a database, etc.? And so this gave rise to the idea of something beyond that, which is Cloud Foundry. Okay, so we'll do a little bit of a demo. Oh, I should have said this at the beginning. I think when we advertised this meetup, we said that it was going to be hands-on. But I see not many laptops, and we kind of figured this would happen. Because we thought today we're just going to give you the basics of what is Cloud Foundry. I'm deliberately leaving links to some projects, which by their very nature are hands-on. And if anybody wants to go hands-on, we can kind of spend some time, and I can get you hooked onto the product a bit later on. And I should mention, for the majority of today, I'm going to be talking about open source Cloud Foundry, which is freely available to download and run. It's on GitHub. But there are non-open source versions out there as well. Okay. Can you all see this screen? Okay. I'm going to go old school. I'm going to use my command line interface to interact with Cloud Foundry. Now, somewhere out there in the big bad world, there's a running instance of Cloud Foundry. I'm going to use our public instance, which happens to be running on Amazon. And in order to connect to it, I downloaded a tool. Let's do that. A command line interface, which is a small little plugin, and I can run the command CF. And there's a whole bunch of commands I can do. Find my mouse. Here we go. Loads and loads of commands. The key one I'm interested in is to connect to a specific Cloud Foundry environment. So this bottom of the screen is getting mixed up, but basically I ran a CF target command, which is, hey, I'm going to connect to this particular instance of Cloud Foundry as this specific user. So it's got my email address. And a couple of points to point out: organization and space. So an organization is just a team. I belong to this team that's called EMEA. And space is just somewhere I want to execute my code. And there may be many spaces in my organization. So there could be a space called dev, test, or it could just be SUFS testing a SUFS random space. So I'm going to push an application, and the application I'm going to push is a Python app. I don't know anything about Python. I'm just using it as an example. How many of you are Python guys, people? One over there, okay. So the command, I'll have to say it out loud because it's cut off at the bottom. Let me try and shrink my screen. How's that? Okay. The command to deploy code to Cloud Foundry is, as you can see, really complicated. It's got 4 letters, push. And that's just going to take the application that's in the current file, current directory I'm in, and deploy it. But I can pass in some parameters. I can say, hey, give me 1 copy of this application, give me this amount of memory, blah, 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 blah. To make life simpler for me, I've kind of captured all this in a YAML file. So I'm going to push an application which just displays a sine wave. I'm saying how much memory I need, and I'm saying something about a build pack, which I'll explain what it is in a moment, and a start command. Okay. So it reads the manifest. It creates a logical application on Cloud Foundry. It's uploading the bits to Cloud Foundry. It's going to do a whole bunch of stuff, which we'll come back to and talk about in a few moments. Oops. So I'm going to come back to that demo very shortly. Just want to skip forward. Just tell you a little bit about the history of Cloud Foundry. So I mentioned pre-2013, a lot of people were working on this thing called Bosch. Around 2013, a new company was formed out of VMware and out of VMC called Pivotal. And we became the owners of the open source code base, Cloud Foundry. We're continuing to develop it and evolve it. We started recruiting people from various different companies. There was a big investment into us from loads of organizations like GE and Ford, etc. We decided that we shouldn't become the owners of Cloud Foundry, so a separate body, a foundation was set up called Cloud Foundry Foundation. They look after the direction, and we're constantly evolving and releasing new versions of Cloud Foundry since that point. Currently on the 8th release. This slide deck is slightly out of date, with version 1.8. Who's in the foundation? Tons of companies. It's not just technology companies. This slide is old. Docker should be on here. Bosch, B-O-S-C-H, the German company should be here. Atos should be on there. But I just wanted to show you that there's loads of companies kind of contributing towards this. One company that isn't on there is Red Hat. For reasons they've decided not to be on it, which we're invited them. Cloud Foundry exists as an open source product, but there are some enterprise flavors. IBM has one. It's called Bluemix. HP, I think, have one. I'm not sure if Micro Focus has it. If you guys don't know, HP have kind of sold all their software into Micro Focus. So they bought Staccato off ActiveState last year, and they had their own version called Helion. I'm not sure where they live at the moment. We have our own one, and we're quite imaginative in the name. We said we're going to call it Pivotal Cloud Foundry because that's what it is. And there's a few other vendors who are using Cloud Foundry as a basis of their PaaS. Back to technicalities. Let's go back to my app. Now, I just deployed this application, and if I just scroll back a couple of lines, you can see what happened. Loads of exciting stuff. So I took this application and said, hey, Cloud Foundry, can you run it for me? And I didn't really tell it much else apart from a name, where the file is located, and I gave it some names of some dependencies. What Cloud Foundry has done is it's created a runtime environment for me, It's analyzed the application, analyzed the code, and tried to work out what packages I need and install them for me automatically. So it's a flip on the model of, say, building a container where you kind of built your environment. You're now asking the PaaS to do it for you, hence platform as a service. So it went off and downloaded all the libraries I needed. It's got it all installed in the correct place, deployed the application in the correct place. And it's actually made my application live. And you can hit this URL now, because it's a public URL, and you can see my exciting sine wave app. So let's do that. It's not the best app in the world, I'll warn you. Question.
Does that mean you didn't have a requirements.txt for your Python application, and Cloud Foundry found out what are the dependencies?
Yes. So for a normal Python app, and languages, the behavior is slightly different. So for a normal Python app, I think you've got a vendor, your own sort of dependencies. But if you're using Conda, I'm not a Python guy. Conda, we're a bit more intelligent. We can go off and fetch. You just have to give sort of names of what you want. And this one happens to be a Conda app, so hence you saw it downloading and kind of doing all of that for you. Okay. And it's a very basic app. It just shows some sine waves. And I can say, hey, I want 10 sine waves and it updates. Nothing fancy, just as a demo. Okay. Now, what I want to explain more is what's going on behind the scenes. Okay. That makes sense? Cool. So, first of all, what is Cloud Foundry? What's going on behind the scenes? I mentioned this Bosch thing before, and I mentioned its job is to create VMs. But when someone needs to stand up a Cloud Foundry instance, you talk to Bosch. You say, hey, give me a Cloud Foundry. And what it does is it says, okay, I'm going to give you a bunch of VMs. And there's going to be some called cells, some of them are running etcd, some of them are called a cloud controller. In fact, what you end up with is a whole bunch of VMs doing different purposes. And the most important ones we're going to focus on in the next few slides are cells, but I'll come back to that. You've got a router. The router is what established the network path to my application dynamically. You've got login servers for authenticating users, making sure the correct users are there and they can do what they were supposed to do. You've got syslog drains to kind of collect all the logs in one place. So you can feed them off into Splunk or Elasticsearch. Loads and loads and loads of different stuff. And by the way, in the early days, Cloud Foundry was obviously just meant to run on VMware, but now it supports OpenStack, Amazon Web Services, Google Compute Engine, and most recently Microsoft Azure. And we constantly want to evolve this. The idea being that now you don't write your app to be specific to AWS. You kind of write it to be compliant with Cloud Foundry. And if you want to switch from AWS to Google Compute in the future, that's fine because you just point Cloud Foundry at a different cloud provider behind the scenes. Okay. So what just happened to my Python app? I ran a cf push command, and that talked to one of those VMs. In fact, it talked to the Cloud Controller VM. And the Cloud Controller VM talked to another VM, the Cloud Controller Bridge. And the Cloud Controller Bridge talked to a bulletin board service, which talked to an auctioneer. And the auctioneer's job is to say, I need to find somewhere who can analyze this application and work out its dependencies. So this is a bit like the scheduling aspect that you can think of, like Kubernetes, for example. So we've got a bunch of VMs at the bottom, cells, already pre-provisioned, waiting for workload. The auctioneer says, hey, how busy are you guys? And they come back and they sort of give their response of what their workload is at the moment. And one of them is selected. And on that cell, we spin up a container in real time, dynamically. And the container is used to analyze the application, work out dependencies, and download all of those. And that's what we call staging. So how do we do that? Well, if we're going to, I'm going to skip that slide actually. If we just come back to this picture here, we've chosen. Cloud Foundry makes no assumptions up front. There are certain languages it can process, and I'll go through the list of languages in a moment. The languages it can process is driven by something called build packs. Are you guys familiar with Heroku? So we worked with Heroku in the early days and this concept of build packs, and we sort of fork that idea a bit more here. So we have build packs, and we download all the build packs to the container unless you explicitly say I specifically need build pack XYZ. Okay, and Cloud Foundry will say, okay, hey, are you the right build pack? No. Are you the right build pack? No. And then finally one of them says yes. So each build pack just has a detection stage. The detection stage might be something very simple as, hey, does this artifact have loads of .class files? Yeah, it's probably me. I'm a Java build pack. I'm going to execute here. Or does it have a .py file? It could be something as simple as that. It could be more complicated. When the right build pack is triggered, the build pack is then is a pre-prepared sort of sequence of steps. It's a script or a Ruby program which says, okay, you've given me an application. I'm going to look at the build pack and I'm going to work out what you need. I'm going to go off and fetch them either from a local cache or from the internet and create what we call a droplet, which is a combination of your app and its dependencies. Okay, and we store that droplet in our blob store alongside the original application that got deployed. So you kind of got two copies. You've got the raw app and you've got the sort of packaged app with its dependencies. Okay. Now I'm going to just go back and demo one other app. So I showed you a Python app. I'm going to push a Java application now just to show how similar it is. So what I was doing before, I was targeting this public Cloud Foundry environment. I'm going to target another Cloud Foundry environment just for fun. I'm going to use something called PCF Dev, which is Cloud Foundry running on my Mac. Small cut down version of it. It's a Vagrant VM. And the application I'm going to push is PCF Demo. Very basic Java app. I have a manifest, as before. And I'm just saying, hey, it's a WAR file. Give me one copy, this amount of memory. It's located in this specific folder here. So I've already built the application beforehand. Cloud Foundry doesn't build for you. It expects you to do that yourself. I just say cf push, and sort of the same sequence of steps occurs. It's created a root, which is the external URL. You can see it's downloading all the possible build packs to that container. And then the build pack that got triggered was a Java one, and the Java one said, okay, I need to install JDK onto this container. I've detected there's a file called a web.xml in the web folder. It's probably a web app. Let me go and fetch Tomcat and install it for you. Let me deploy your application to the right location in Tomcat. Let me tell the router that this app is available at this particular IP address. And then immediately the application is there, it's ready. Usually this would take 2 minutes. Because I'm running on my local Mac, it took about 10 seconds.
What takes the time? Just uploading the one?
Uploading, that's some of it. It's more the analysis and saying, oh, I need to fetch this library, I need to fetch that library. It's depending on those speeds. But in that time, if you think about what's going on, it's spun up two separate containers. So one container to do the analysis, and then that's kind of thrown away. And then another container to actually run your application. And so that we've got a clear separation. That makes sense.
Does that mean public Cloud Foundry is less performing than your laptop?
No, just because if I'm going over the World Wide Web, that sort of creates a delay in a sense.
But still, your application has to download its dependencies. Did you have it cached on your
I had them cached here.
Right.
Yeah.
So it doesn't cache them in?
I cleared out the cache beforehand. Yeah. I'll just kind of make this kind of run smoothly as possible. So this application I'm using is just a very basic demo web app. It's just a map of Europe. I pushed it to Cloud Foundry. What I can do is I can say, hey, tell me a bit more about this application. If I run a cf apps command, it tells me, hey, I've got an application called PCF demo -suf. I can get a bit more information specifically about this application. It's running, cool. I can scale it up a couple of times. So you can see it's running, and I can access that one application that's running. But what it's doing is it's creating 2 more containers. It doesn't need to analyze the application anymore. It did that already. That's why we cached that droplet. And it can just apply the same droplet across onto those 2 containers. You've got 3 running. And now Cloud Foundry's router will balance requests across those 3 instances. I did it manually, but we obviously have auto scaling built in, and it's a feature that you can have in there as well.
Is it round robin? So
Yeah, it's round robin. So this demo app was written to kind of show the IP address of the particular container it's running on. So you can see at the top there. With luck, because it is round robin, the IP address does kind of fluctuate. Okay. This demo app was designed to show that if you were to kill one instance of the application, you should see it was kind of too quick. One instance failed, and then it recovered the situation. So it's monitoring your apps as well as monitoring the underlying VMs and infrastructure that you're running on.
So did it set up another instance?
Yeah, it ran another auction, and it decided where's the most appropriate place, and it found another container to run it. Okay. Yeah. Is that a question? Yeah.
Load balancer is another container running on the VM.
So in a normal Cloud Foundry environment, all of the stuff that isn't an application are real VMs. Because on my Mac, everything's just containers, because it's too tight to kind of squeeze it in.
Well, we can't see it here in the status, so it's not something that we can manipulate or we can have access to.
So give me a reason why you'd want to manipulate it.
I want to implement my own load balancing algorithm, for example.
So you can't manipulate it, but all of the code is in GitHub, and you can fork it, and then you can tweak what you want.
of course you can point to your own load balancers and HA.
So before Cloud Foundry, the ideal deployment is you have a real HA proxy or load balancer, which is meant to kind of capture traffic to your domain, and then you tell Cloud Foundry, hey, particularly I want you to go route to app 1, and that's kind of like a sub-level of routing, if that makes sense. Yeah. Okay. So apps running. We've got a couple of instances. This particular app was written to connect to a queue, and it's kind of a silly app. The same app puts messages on a queue and reads messages back off to a queue. But it's worth showing how you can get something like a database, or how you talk to external services. So in Cloud Foundry, you have something called a marketplace. Now what the marketplace is where the person who administered and operated Cloud Foundry sort of declared these upfront as these are the external connections, or clusters that MySQL itself is managing. So in this particular case, on my Mac, I've got a MySQL 1 single node environment, RabbitMQ environment, and Redis. Okay, and I can say, hey, create me a service of type RabbitMQ, and give it a label called, I'm going to give it a plan. My mistake. I've forgotten standard. Here we go. Just shows you the plan there. P Rabbit MQ standard, and give it a name, MyQ. And then to link my app to this instance, whether it's a database, the command is fairly simple. You just say bind PCF demo -suf to MyQ. Bind service even. This is the dramas of doing something live to people. Okay, now the way my application is written, it doesn't automatically realize if there's the queue connection has been supplied. So I just kind of need to restage it, which means just sort of restart almost in a sense. So I'll do that. It goes through that staging process, does the analysis. And the reason why we're doing a restaging is maybe I could have added a dependency that needed it to go and fetch a MySQL JDBC driver or some kind of connect. So it needs to double check if there's any additional libraries that are required. So
actually deleting the instances then, and then recreating.
In this particular example, yes, but there's ways to avoid that. There's ways to kind of go around that. Just my app was written pretty badly.
How do you deal with persistent storage?
So if your app has, so you mean like a database?
Yeah.
So you're saying like if I'm killing, all I'm doing is I'm killing the application rather than killing the database here.
Database is somewhere else.
Oh, okay.
Yeah.
So databases are not containers. Do they come from Bosch?
Yeah. Okay. Or they could be running completely out of Cloud Foundry. Could be running in a cluster or something else.
So when you do marketplace, it's
Yeah.
not actually listing the containers that you can access, it's listing the services that you can access.
Yes. Yeah. So, yeah, good clarification. So now I've got a binding as such between my application and some service. So the binding, the way it's defined in Cloud Foundry speak is everything we're running is in a container and we support multiple languages. So what's common to any language? Well, an environment variable is common. So if I ask, what are the environment variables for my application? I can see this entry here, which looks horribly complicated, vcap services. And inside it is an entry for a queue. And it's got all the credentials to access the queue where it's stored. And somewhere on it is the label my queue. Like, I can't read JSON very well, but it's somewhere in there. And so at the worst case, the code just needed to know, look at the environment variable, find the entry that's labeled my queue, and then you find all the information that you need in there. So as long as it always knows my queue is its place to go, then when I push it to dev space, test space, prod space, it'll get the correct credentials. The code can be consistent across all of those. If you use Spring, then there's some additional Spring Cloud libraries, which will just do it for you automatically. You don't even need to write the code. You just declare dependency on database provider or messaging provider. Okay, so does that make sense? And I'm kind of whizzing through.
Just one thing, can you pin applications, versions of applications?
So you explain that a bit more, yeah?
Let's say you, as an example, you're using Java 7 instead of it downloading the latest version of Java 8. So can you say that I only want to use this particular version?
Yeah. So when you do a push, I was just literally saying push. There's loads of additional parameters you can supply. And so some of them control the behavior of the additional flags you want to send to the JDK. So I specifically use this one. There's so many different ways you could do it. You could pass in parameters, or you can have a copy of the build pack which only has that JDK in it, and you can say, hey, when I'm running this app, I want to use that specific build pack. It depends how you want to operate. So where I always joke that we're very secretive at Pivotal. It's kind of the exact opposite. If you go to our documentation page and click on Cloud Foundry, got a section here for build packs, and the build packs lists the official languages that we support, explanations of what they do, and the actual source code for the build pack, which is more information. So for example, some customers say, really like the Java build pack, but specifically when we push an app, we only want it to be running if it's contained this .license file or some sort of file which validates it's gone through some kind of approval process. And so fork the build pack, add that logic to it yourself, and then you've got the behavior you wanted. Yeah. And when you do the push, developers can say, it's just a simple parameter -b, and they can point either to a URL of a build pack, a label, which refers to an actual build pack that's been deployed to Cloud Foundry, or alternatively, you can say, I only want people to use the build packs that I've deployed. So you can disable the ability to kind of define it at push time. Does that answer your question? Sort of. Yeah.
What's the language the build packs are written in?
So build packs can be written in either shell script or Ruby. Okay. And, Cloud Foundry itself is written in Go. It was in Ruby a few years ago, and it got rewritten recently to Go. Oh, actually, I just wanted to click on here. So just on your specific question there, I was reading this earlier on. Java. Oh, here we go. Here's an example. You could set an environment for your app which says, hey, I specifically want to use this version of the JDK, and you could put plus parameters there. You can put ranges, etc. Okay. Now, just coming back to here, so we can skip through a couple of steps. After the staging, a very similar process happened. We know what the application needs. We need to find somewhere to run it. We go through a sequence of steps. The auctioneer says, okay, find me somewhere that's free. The cells come back and tell them how many is available. And then it may decide this is the cell that's available. It creates a container. The container technology we're using is our own container technology. You can push a Docker image to Cloud Foundry. You don't have to push jars, wars, or Golang app. You can push a Docker image. Currently, we translate that Docker image into our own containers. But we're modifying Cloud Foundry to support the OCI, Open Container Initiative. So in the future, it could run a Docker container, it could run ours, it could run Rocket, anything that's compatible, assuming Docker formats don't explode and go triple-fold in all different directions. The containers are all run C, so they're isolated, separate namespaces, separate process IDs, completely isolated. They started up on a random port for security reasons. You can't directly access them unless the operator has ticked a box in the configuration of Cloud Foundry, allowing that to happen. And the reason why default is to prevent is from security perspective, to kind of keep it all locked down. And once the application is available, you get a route by the router. Okay. Now, what I should point out, I guess, is I know I'm going to focus mainly on open source Cloud Foundry. I just want to show you briefly one of the features that you get with Enterprise Cloud Foundry, which is this user interface for application developers. Okay. Now, one of the Cloud Foundry environments I was playing around with was this one here. And I pushed an application called SineWave. And it got given a route, SineWave, blah, 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 blah. But you can map multiple routes to an application with multiple domains. So I can now access my app at both of these routes. So why is that interesting? Because typically what people do is they push an app and they give it a route, which is app name dash version something. And then they can run some tests, and then they can assign a public route to that app, my app. And then when they're deploying version 2, they can deploy it somewhere else and just give it a label version 2, run some tests, and if they're happy, then they can assign the route, my app, to both version 1 and version 2. And they can scale one up and scale one down and kind of try to seamlessly go across. What that doesn't kind of counter for is, behind database schema changes, that's something you need to synchronize yourself in terms of your deployment. But at least it gives you that level of control. Okay. Right. Containers, I'm sure you all know containers have been around since before Docker days. We've been supporting for quite a while. Our containers used to be called Warden. We rewrote Cloud Foundry to be in Go, so we called our containers Garden because it's got a G in it, G in the front. We're working with different vendors to kind of harmonize it. The difference, as we see it, is in, say, a Docker world, you're building an app and then maybe you're doing a bit of extra work. In a Cloud Foundry world, you're bringing the app and we're doing that, most of that for you. Okay? So we're providing the runtimes, we're creating dependencies. And then patching and maintaining of all the operating system is then simply done for one simple user interface. So again, just looking at the enterprise version of Cloud Foundry, there's another user interface which an operator can see. And this allows them to administer and operate Bosch, in a sense. So each of these what we call tiles. And each tile you click on and you can configure. So, for example, I'm getting my Cloud Foundry environment is running a Jenkins cluster. And I can click on this tile and I can configure that cluster. I can say, here's my license file. This is how many nodes I want. And then I can click on status and it's showing me I've got probably one master, 2 slaves, etc. And it's all kind of centrally managed here. And I can grow things and shrink the size of this cluster as needed. And it's the same for any of those tiles for MySQL, Rabbit, or Redis. So whatever gets configured here in this user interface or via Bosch's command line is what I as a developer see in the marketplace. Okay. Question, I think.
I have a question.
Yes.
So you mentioned that the UI that we get using, is interface that we saying is for Cloud Foundry Enterprise.
Yeah.
So that's still
The functionalities is still there in the open source,
right.
but you kind of need to become a master of Bosch.
Is there like an open source interface for Cloud Foundry? Yeah.
So some companies who are using open source Cloud Foundry have made their own interfaces. I'm not sure how many of them have been made available in the community, if I'm honest. I don't know if you've got a thought on that.
Well, I mean, I don't know what we're doing with ours because we've done it. We've built one. But like I said to you before, we're more interested in services than anything else. So are we going to sell it as a licensable thing? I don't know. Are we going to give it to our customers, or are we going to fold it backward into the open source? I don't know. I can show it.
Basically, our Cloud Foundry distribution is open source Cloud Foundry plus other bits. The UIs being some of them. Some of the other vendors have taken open source Cloud Foundry and removed bits. So, they only want their Cloud Foundry to work on their infrastructure, for example. But just coming back to build packs, as you show, we support all of the Java framework libraries, Ruby, Rails, Python, Node.js, PHP, Golang, and most recently we added .NET support. That kind of went hand in hand as well with Azure support. Obviously, Windows doesn't support containers yet. We are playing around with .NET Core, which is kind of giving some of that functionality. We recently had another round of funding, and Microsoft was one of the investors, so they're quite behind our strategy. So we now have EMC, VMware, General Electric, Microsoft, and Ford kind of investing in us and helping shape the direction. You've got the foundation, which is kind of helping kind of gear the strategy. So this is going to grow. The containers we support is going to grow. The cloud providers we support is going to grow, hopefully. Does your app need to be anything special? Do you need to build it in a certain way? How many of you have heard of 12-factor design principles? Cool. Okay. If you haven't, the website is 12factor.net. It's a set of design principles that are created by Heroku, and they sort of describe the ideal cloud application. And the real prerequisite of any app to run on Cloud Foundry is it must be 12-factor compatible. Your ear file is not going to run on Cloud Foundry. Or it's going to run, but it's going to run pretty badly. You're going to need to do a lot of legwork to make it work. So what is this all about? It's kind of principles like, if your application takes 4 hours to start up, what the hell are you doing? Get out of here. Because in the cloud world, the underlying infrastructure where your app is running might suddenly die. And the PaaS is going to try and recover that by starting up a new one. If it takes 4 hours, that's kind of pointless. Right? Similarly, if your app is keeping all of its state in memory in the same memory space where your application is running, when that instance dies, the application dies. If you use something like Redis or something else, then that's kind of cool. So, and if you have your configuration hard code in your application, say URLs of your database, and you push it to Cloud Foundry in dev, that might work. And then you push that same app to test, that's not going to work. Rather, your app should be written in a way that it can receive credentials in at runtime, get injected in, so via an environment variable, and you can kind of adapt dynamically. Okay. Okay. I'm doing a lot of talking. I hope this is interesting for you guys. I don't have many more slides. Coming near the end. We think of Cloud Foundry as the home for microservices, an ideal kind of runtime environment for microservices. But microservices don't run in isolation. They talk to each other. It can get very messy. How does one microservice talk to another microservice? Here's another demo. So I've got another application here running in yet another Cloud Foundry environment. It's the world's most complicated application. It doesn't have a UI, it just has some RESTful endpoint which displays a list of cities. this application talks to a database and exposes some endpoints. So we can see it's running, it's connected to MySQL, and MySQL is where the data is stored. Are you guys familiar with Spring Boot? Spring Boot app, 6 lines of code. That's it, really nice and easy. Now I want to build another app which acts as a sort of a web layer that can consume this data. So the 2 microservices need to talk to each other. So I'm going to grab this URL and I'm going to make sure I'm going to deploy to a completely different PCF environment. Cool. And I'm going to go to my app. And I'm not going to run push. I've got a shell script which automates some of this. My shell script just does build, deletes any previous copies, and tidies up. And we've got this command called cups, create user provided service, call it city service, and here's the key data. And that's going to be the URL of my other app. Okay. So I know this one is wrong because I always have a random word. And it's something like this. I don't need that. And my vi skills are bad, so I forgot how to go to the beginning of a line. Okay, so that's just going to run a Gradle build. It's going to push the application to a different Cloud Foundry environment. And with a bit of luck, bearing in mind I'm doing a live demo, it's going to work. Okay. So what I'm doing there is kind of doing a very sort of hard-codey way. I need to know the URL of my target microservice, and I need to tell my other one what that URL is. Okay. Anyone see a problem with that? There's nods of the head. Or there's, well, one of the problems I see is one of the biggest users of Spring are Netflix, and they kind of had this problem, and they kind of felt like, well, there's a better way of doing this. And they're not the only people who do it. So there's things like discovery servers, right? Shouldn't I be using a discovery service to try and find different microservices? Okay, so you can do that in Cloud Foundry. I'll let this kind of deploy, and I'll explain a bit more about that. So we worked kind of in combination with Netflix to understand some of the OSS design methodologies, so configuration servers for storing, configuring external repository, discovery services, circuit breaker dashboard. Very familiar. When one microservice falls, then you just close the switch, and you have a fallback. And we've kind of added them to the enterprise version of Cloud Foundry. So the reason I'm showing you this way is this is the quick and easy way of doing it in open source, unless you build your own configuration server yourself or discovery server yourself. So with a bit of luck, I can click on this URL. There you go. So it's just a nice, pretty web app. Just relying on the other one, it reads the list of cities and presents it in a nice, pretty format. As I said, there's better ways of doing it. The enterprise version of Cloud Foundry comes with the ability to do some funkier stuff. Let's skip all this slide. So we've got some Netflix OSS components built into it. We've got curated ability to spin up usual my UI, MySQL cluster, Cassandra cluster, blah, blah, blah. And you've got some nice kind of funky metrics, sort of New Relic style, App Dynamic styles. There's loads of other kind of stuff in the enterprise version. If you want to see an example of using the Netflix sort of stuff, this is a demo application written by one of the guys who works for me. It's 4 microservices, sorry, which form together to create a trading application. I believe I've got it running here. So it's kind of like a trading app. It's got real-time trade, and you can fictitiously buy some stocks and sell them and sell them on. It's actually 4 different microservices with different purposes. If I click on the services tab, those are components it's using. It's got circuit breaker, it's got service registry. If I click on service registry and click on manage, each microservice basically started up, connected to it, and registered itself with its name. And then it's only this component which knows the end URL of each one. So any clients who need to access it can get it from here. Do you want to take a picture?
Yes, I want to take a picture of the URL actually.
Of the repo?
Yeah.
Yeah, sure. Okay.
Presentation.
Yeah,
Can you just share the present?
I will. But,
That's great.
he's all about the live.
So how do you inject the URL into your application? Is it the environment variable?
So in that version, each of those applications on startup just talks to the discovery server and say, hey, I'm called accounts. This is my URL. Hey, I'm called quotes. This is my URL. And if quotes needs to talk to accounts, it just goes to the discovery says, I need to connect to accounts. So all it's knowing is the label rather than the URL. Yeah.
Is that specific to any one language stuff or any language?
So at the moment, it's great for Java and Spring apps only. We're working on something called Steel Toe.
Yeah.
Don't ask me why it's called Steel Toe, but that's for .NET apps. Okay.
Doesn't it use DNS, the service discovery tool? So can I just say, ping accounts from my application, and it will automatically get an IP and talks to it, or?
Well, what's the IP of accounts? So you're in a cloud world, you deployed accounts, it's got an IP address, then that one VM or that one container crashed, and another container was created. What's the IP address now?
Yeah,
So something needs to, and that's why it's.
So like in Docker Swarm, you get that. It's their own internal networking. So the IP only results within the container. It doesn't result outside the ecosystem.
Sure.
So that it's, yeah.
I mean, I think what we're trying to move towards is, so these microservices may eventually be running in different Cloud Foundry environments, not necessarily within where everything knows each other. So it's more about the root rather than the IP, if you see what I mean. Yeah.
Does the router not take care of that? If you were to hit accounts dot whatever, then it would go to the root, and then that would be.
So if all your, let's say that's now all your microservices running in the same environment, then yeah, you could say I'm going to accounts dot blah blah blah. It would probably work. What if account is running somewhere else in another Cloud Foundry environment? And you don't know what a domain of that is. It's trying to give you more flexibility. Yeah.
What about non-HTTP, non-web? Yeah, so let's say I'm running MySQL, or not MySQL, like Cassandra.
Something, yeah.
It's just
At the moment, yeah. So at the moment, our discovery implementation is just from HTTP. Okay.
Steel Toe is a wrapper for boot. Think about it, Spring Boot, right? Must be.
Must be related to that.
Yeah.
Last thing I was just going to talk about, are you guys familiar with Concourse? Don't know if you've ever heard of it. A developer in Pivotal London a few years back was really frustrated with other CI tools out there. So he built something called Concourse. It's available now, concourse.ci. It's free, publicly available. It's pretty. It looks like this. I think I've got an instance of it running over here. So this is, for example, the pipeline for one of my apps. It's pipeline as code. So this is one YAML file which references other YAML files, and each YAML file describes tasks. And the only reason I show is not to show off Cloud Foundry or Concourse, but just to show the relationship between CI/CD and where Cloud Foundry fits in. Cloud Foundry is about giving you the environment to run your app, and then monitoring your app once it's running. It doesn't do source control. It doesn't do builds. It doesn't do tests. So this pipeline says, okay, I need to talk to Cloud Foundry, and I need to create a brand new space from scratch because there's been a change in the source code. It doesn't have to work that way. You could put a condition in there. Run some tests. If the tests pass, deploy to Cloud Foundry, and then test the application on Cloud Foundry. What does that mean behind the scenes? because I'm using Concourse, Concourse uses Docker. So it'll look at my source code and create a discrete Docker container for each task to do a very specific job. So some of those jobs might be just to log in, connect to Cloud Foundry, do a test, then log out and kill the container. And some of those might be log in, connect to CF, and deploy an app. And so they're a good combination of the different sort of technologies. Cool. There's no more demos. We are hiring as well, but I just plug that in. Okay, cool. I hope that was really useful. Any questions after that?
I have some operational questions.
Yeah, sure.
First of all, how expensive it is to run Cloud Foundry, like from the money, like basically money and the budget that we need to get.
Yeah.
Secondly, about
I'm taking my jacket off now. You're making me sweat now.
this is gonna
It's tough, right?
Yeah.
How hard is it to maintain? So let's say Cloud Foundry, like do I have to create a VM and install Cloud Foundry cells or configure it for cells, or does it do that somehow based on, I don't know, like scripts that are coming with? And how do we maintain it? So I want to know, like, we have to have a Cloud Foundry team in my organization to take care of this, and what's that overhead? Is it easier than just going to Amazon ECS and just say, here's the Docker that I have, can you just run it for me?
Yeah. So let me answer your questions in reverse. Do you need a Cloud Foundry team? Probably, most likely. What's the difference between just having a team looking after AWS? Or do you want to only ever be running on AWS? Just using it as an example. Or do you only ever want to be running on Azure?
Yeah.
Or do you want to have a PaaS? And remember, CF could be RCF, could be open source CF, could be IBM's. You're not just being locked into Pivotal. You're being locked into that technology. Some of the companies that I know of who are using open source Cloud Foundry, there's a publishing company here in Europe, not too large. They have 15 people full-time running and operating open source Cloud Foundry. I think that's kind of excessive, if I'm honest. On the flip side, we know people who are running enterprise Cloud Foundry, and they have 2 people, and that's a large bank, right? And so it's just with anything open source versus commercial, the open source one always has more effort, and there's a particular skill set that they need to learn and be on top of. Specifically, you need to know Bosch inside out. Bosch is YAML driven, and if any of you use YAML, one space, and your life's ended for the next decade, right? If it's out of place. But there are companies out there who have been using it for quite a while. So what's the cost to them? Software-wise, no cost, because it's open source. Perhaps there's a cost in the human resource. I don't know how much that costs, what the value of that is. Enterprise Cloud Foundry is not free. It costs money, and I can discuss that with you offline. But I'm not a sales guy, so and it comes down to you thinking, okay, well, what would I ever have? You know, would I have a team, or would I have supported software? If Pivotal's been going for 2.5 years, when I started at Pivotal, Cloud Foundry could run on VMware, just about OpenStack. Now it runs on OpenStack. Now it runs on AWS quite comfortably. Now it runs on Azure and Google Compute. We're talking to those people. We've got 300 engineers globally kind of working on the product. Some of our customers who are on the open source version are quite happy, but they can't run .NET apps on Cloud Foundry because they've customized their implementation. But maybe they're happy with that. So it's a choice of any open source version. Good questions. Did I dodge the pricing question well enough there? Cool. Yep.
You showed us how to pin to a specific version of Java. Do you go a little bit beyond that and to sort of version your whole bill of materials for your server?
So what do you define as your bill of materials?
Everything from
like Tomcat.
Everything from the OS up to the packages.
So first of all, let's talk about the OS. The price of a PaaS, and I'm using the word price, is actually your OS is our OS. It's our responsibility now, or the Cloud Foundry provider. So all of those containers and VMs that are being constructed, Cloud Foundry is using Ubuntu Linux, and Ubuntu Linux solely. And Windows is a different story, right? So what that means is when there's a critical vulnerability in Ubuntu, we release a patch on our website within 48 hours. You download that, you go to Cloud Foundry management, and you say apply, and it does a blue-green release of that across all the VMs. So in a way, you kind of don't have a choice there, right? Because we're just taking that problem and burden away from you.
Yeah.
Now refining a bit more, Tomcat versions, everything is configurable via the build pack. So if you think about the VM and the OS, that's sort of a step that Bosch does, and it's within the control of the product. Now you're layering software on top of that. That's where the build pack takes over. And the build pack is customizable to as much as to whatever you want to do. It's a public repo. It's got flags which you can pass in to control behavior, or you can completely fork it and change it and modify it.
I'm thinking more from the use case of, let's say I push my app, and
Yeah.
it's not ready developed,
Mhm.
and then in a month's time, traffic goes up, I need to scale up a bit. How do I know I'm going to have the same build of materials on the extra servers
Right.
than the normal other ones?
Because so the OS level is all packaged in what we call a stem cell.
Yeah.
Stem cell is a very bare bones OS. So every time we create a new container, you're applying the same stem cell, you're applying the same build pack, and you should be getting consistency. Where we would deviate perhaps is if you, well, even if you applied a patch to the operating system, you're patching your current one as well as future ones. So everything should always be at the same set of rules. It should be immutable infrastructure that you're getting, in a sense, right? You should be getting a repeatable pattern. You just have to trust me on that.
Okay.
Did you not say that it saves the image anyway? So when you scale up, you would physically get the same.
Yeah. Do you remember I had that droplet icon?
Yeah.
Yeah.
So is it fusing the two together at that point, and that's
Yeah.
actually
That's it. So unless you then deploy the source code again, that's the definite of current state, current deployable. So when you do a scale, we basically create a new container, put the stem cell on it, put the droplet on it, and the droplet is those layers of libraries. Yeah.
So Cloud Foundry is going to manage all those images. There's going to be probably an image per version of every app that's running.
Yeah.
Okay.
So it has a blob store, which stores all those images, as well as associated metadata. So for example, in my case, I did a push and I said, give me one copy, does amount of memory. That's the metadata. And then there's a couple of blobs, the original blob that I passed in, and the blob which is app versus plus libraries. Yeah. Okay.
Cloud Foundry actually look after the cells themselves.
Yes.
So that what happens if you get a performance issue with one of the apps? Can you actually drill down to which cell is actually causing the problem? If you've got many apps running across many different cells,
Yeah.
then you want to be able to drill down to which one's causing the issue.
So open source Cloud Foundry, no. In our enterprise version, we added something called PCF metrics. Now, because if you think about it, we kind of have an idea that the request comes in and we're directing the traffic to those cells. So we've always had that metadata there, and we've decided to kind of capture and productionize it. So what PCF metrics does, it gives you the ability to say how busy an app is, what's its kind of threshold, what's the CPU activity like, what's its typical response time, is it deviating. Now, we're not trying to compete with, say, AppDynamics or New Relic, for example. PCF metrics is a 24-hour snapshot at the moment, and that's what it is. Yeah. Probably when you really want to get more deeper, then you would probably rely on an APM tool like that to kind of give you those sort of thresholds and alerts and automatic triggering. So what some customers do is they'd say, monitor my app. You might just tell Cloud Foundry, so our autoscaler works on CPU thresholds, and you might just say, hey, if I get above 60% CPU, give me 2 more copies. And if I get below, then go back down. But if you want something more sophisticated, then maybe your APM tool could look at the size of your heap, and if your heap is growing, then trigger another Cloud Foundry command to do something intelligent. And you kind of can orchestrate that out to the product. Does that make sense?
So those APMs are not going to tell you which stem cell is the problem, right? Which stem is the problem. But it doesn't really matter though, does it? Because it's going to tell you which app instance the problem. You
Yeah.
might have 4 instances of that same app, but they're all the same.
Yeah, but if you've got a cell that's continuously busy for whatever reason, because one application is completely using that cell, then you're always going to have one cell that's out of use because it's being handled by one app.
So when you're saying cell, you mean the VM running the
Yeah.
containers? Yeah.
Yeah.
So we always try to distribute. So if you push an app and you can scale up to 4 instances, we'll try not to keep the other instances on the same cell. We'll try and spread the load across all the cells that we have. So in theory, one app shouldn't take a cell down. If that makes sense.
Right.
One app might take.
So a VM is, you've got many VMs in one cell.
The other way around.
A cell is a VM.
Yeah.
And that VM may have many containers.
Oh, okay.
And so if you've got 2 cells and you'd ask us to deploy 2 copies of your app, there'll be 1 container here and 1 container there. And we'll try and spread the load as you increase the scale.
If you're like just running stuff on public cloud, do you have any fees to pay outside of what you pay Pivotal? So do you still have to pay for the AWS inbound and outbound or whatever kind of thing?
So PCF has a footprint. So if there's an AWS, that's, well, I'm going to use VMware because I just know off the top of my head, PCF occupies about 27 VMs. Something similar on AWS. You're going to pay for that cost of those AMIs as well as Cloud Foundry. And the cost of your infrastructure as well. Do you get all the great and fancy features that AWS offers you? You get enough, but we are generalists across all of the providers. So I forget spot request, for example, is something AWS, spot pricing, sorry, something AWS does, but Azure doesn't yet and Google Compute doesn't. So it's not something you can take advantage of in PCF. I'm telling you this and being honest, and that's why you're getting a general platform. So, so take for example Comic Relief. They started using Cloud Foundry a couple of years ago. They have all their apps running on Cloud Foundry pointing at VMware. And as the night increases and the number of kind of calls come in and the workload increases, they've reached the capacity of their internal data center. They spin up another Cloud Foundry pointing at AWS, and that's their burst capacity. And it gives them that power to be flexible that way. Other customers work differently. They think, well, we're never going to run in the public cloud for our real production data and production requests. But what about when we're just doing dev and test? So their model is different. They use Cloud Foundry pointing at public cloud, dev, test, and kind of non-important environments. Prod and pre-prod is running Cloud Foundry on-prem. And that's why CF gives them a great use case, because they're not tied in and they don't care that they're missing out on specific features. You see what I mean?
So like, if I get it right, the public cloud use case is that you're still very much using your own AWS credentials or Azure credentials, whatever it is.
Yeah.
Pivotal stuff just goes on top to help you
Correct.
manage.
Yeah. Cool. Any more questions? Awesome. Thanks, guys.
Just keep it.
Cool.